Okay, it's Jeff Badger, the Grinding Doc, and I am here in the Rush booth, Rush Machinery, at IMTS, and we're going to talk a little bit about truing of wheels. Truing, dressing, some people use the term interchangeably. We're going to talk about truing of wheels. I was involved in a project with Rush. My colleagues, Peter Krynick and Radovan Dražumerić at the International Grinding Institute, were involved in a project where we looked at truing of diamond wheels. I guess you could say CBN too, but diamond is pretty much the main one. And my whole life is grinding. That's what I do, is grinding. And there is a lot of information out there on grinding, using the grinding wheel to grind something, say grind tungsten carbide or grind steel. There is almost no information on truing. Now, truing, in a sense, is a grinding operation, where this is the grinding wheel and this is the workpiece, because we're trying to remove this, even though we consume a heck of a lot of this. But there's very, very little information on truing. So my colleagues and I went back to first principles of grinding, and then we did a bunch of tests at Rush Machinery in upstate New York, where we took various truing wheels and various diamond wheels and trued and trued and trued and trued. And then we took different truing wheels and we trued. Then we took different diamond wheels and different grit sizes and different bond types and trued to figure out what's actually going on in truing. And if you're not familiar, truing is basically we take a silicon carbide or aluminum oxide wheel and we grind the grinding wheel. It's a grinding operation, and we're trying to make this guy flat, or maybe put a radius on there. This is a 1A1 wheel, so we're going to make him flat in this case. And the questions are, how do you do it? What parameters do you use? Most importantly, what type of truing wheel should you use? So we investigated all that, figured it all out, and then came up with recommendations for what type of truing wheel to use, and then what type of parameters to use when you're actually doing the truing. So let's talk about grinding wheels first. The most common grinding wheel you'll see out there, most common truing wheel you'll see out there is a 60H wheel. 60 grit size, H hardness. People love them. They're common, they're everywhere. Why do people love them? I would say people love them because they're cheap and plentiful. You can go to Walmart and find yourself a 60H wheel. Our experiment showed that 60H is really not a good choice. Now, why is 68 not a good choice? For most wheels. Number one, the grits are too big. So if you're trying to dress, let's say, a 320 mesh wheel or a B57 or D46 diamond or whatever, if you have a 60 mesh, those grits are too big and it's inefficient. But even worse is if you have an H hardness in this wheel, that means that you don't have a lot of bond material holding it in. So when the aluminum oxide or the silicon carbide wheel goes to battle with the diamonds, and we want the silicon carbide or the aluminum oxide to win the battle, to bust the diamond out, the silicon carbide is probably going to lose the battle. Why is he going to lose the battle? Because there's only a little bit of bond material holding that guy in place. So we need that one to be harder. So not to give away all of our secrets, just to give away some of the secrets that we learned in our experiments, 60H is a bad choice. Almost always, a few exceptions, stay away from 60H. The grits are too big, number one, and the hardness is too soft. Go smaller, bigger mesh size, smaller grits, and go harder, okay? And when I show you the truing program in a minute, we'll give you some recommendations for specific Rush wheels that they will give you the wheel that we found works in a lot of applications. Now, if you get a little bit funky in terms of diamonds, if you're going for really small diamonds or a really hard metal bond, there are some exceptions. But in general, 60 is too big, H is too soft, and you really want to go smaller than that and harder than that. Okay, so that is point number one. Then we studied whether aluminum oxide or silicon carbide would be better for truing. Some people like silicon carbide. The theory is, well, silicon carbide's a little bit harder than aluminum oxide, therefore it should be better when it goes to battle those diamonds. Our experiments found that really there's just not much of a difference between the two. The exception might be if you have really fine grit size, then maybe go silicon carbide because it's more friable. But in general, aluminum oxide, silicon carbide, don't fret too much about it. Either one is fine for the vast majority of operations. Now, 60H is not fine, 60 is not fine, H isn't fine, because that's too big and too soft, but 60H in silicon carbide or 60H in aluminum oxide, they're both bad. In most cases, go with something smaller and harder. But silicon carbide versus aluminum oxide, we didn't see much of a difference. So I'm cool either way. Then we've got parameters. Should we go unidirectionally? Anti-directionally? What should we do with the RPM of this and the RPM of this? What should we do with the depth of cut? And what should we do with the traverse speed? Surprisingly, we found that there was really a lot more influence in the wheel than there was in the parameters, but still, we give recommendations in the parameters in the truing calculator that I will show you in a minute. So, but in general, the main things are stay away from 60H, go for something smaller and harder. Silicon carbide, aluminum oxide, I'm cool either way. Doesn't seem to be a big difference there, except for maybe with very small diamond grits, you might want to try silicon carbide. And then in terms of parameters, we'll talk about that next with the program that we developed, where we went and figured out, based on first principles of grinding, how do you choose the parameters for truing. So let's talk about that now. Let's take a look at the program we developed with my colleagues at the International Grinding Institute for calculating parameters and choosing a wheel. So let's type in Rush Machinery to Google, and I'm feeling lucky. Let's see what we get. I'm feeling lucky, and it takes us to the Rush site. And then in the Rush site, it has the truing parameters calculator. So let's go there. And then we put in some parameters. So we start off with the diamond wheel that we're truing. And then down here, we can put in the current truing wheel that we're using. So let's say right now we'll start off with a 6-inch wheel. Now we can go imperial or metric. Let's go with imperial. And let's say the diamond wheel width is, let's say, 1/2 inch. And let's go with a typical diamond grit size, maybe for carbide, maybe 320 mesh. And then diamond wheel hardness, for grit size, we can do FEPA, or we can do the mesh, either way. And then the diamond wheel hardness, resin bonded wheels tend to be easier to true. Metal bonded wheels are more difficult to true. High concentration, metal bonded wheels. So if you want a starting point, let's put in medium. We can go soft, medium, hard, super hard. So let's go medium, diamond concentration. Most of the diamond wheels I use, say for flute grinding of carbide, are about 100 concentration, so that would be medium. And then diamond wheel chipping tendency is, are you worried about busting off little edge of that diamond wheel? Sometimes that's a bigger issue than others, especially if you're going to put some kind of funky geometry in there. And then we go to the current truing wheel. We have a choice. We can go with the Rush wheel specification or the custom wheel. Let's go with custom wheel, and let's throw in, say, an 8-inch wheel. Let's say it's 1 inch wide, and let's say it's a 60H wheel. That's a popular one. And if we do that, and we say, okay, what's the traverse velocity? We just did low, medium, and high because people typically don't know their value in inches per minute. I wouldn't obsess about this too much. If you're not sure, let's just go with medium. And then we do calculate. And if we do that, what we say is, okay, if you want to stick with your 60H wheel, we are not a fan of the 60H wheel, but if you're a fan of the 60H wheel, we recommend these parameters. We recommend you take 1.5 thou. Some people get timid when it comes to truing. Some people take 1/2 thou. I've seen people take 40 millionths before. But I'm a fan of 1 thou, 2 thou, something like that. And then when you get closer to the end, cut that down sort of kind of as a spark out, if you want to call it. And then truing wheel, you can go 500 RPM, 700 RPM, and anti-directional. And we'll talk about it in a minute. You can force it to go uni. So if you want, you can, some machines can only go uni, and then some people like to go uni because they don't want the swarf flying out in odd directions. So if you want to force it to go uni, you can. This one suggests anti. So if you want to stick with a 60H wheel, here's what we recommend. But we think you should probably go for this wheel. And remember, I said big and soft is not usually the way to go. I want you to go softer and harder. So all things being equal, let's say, for example, if you had a 60H wheel, you would probably be better off, for a typical example, with a 100K or L, something like that. Our test that we did at the Institute found that once you get above K, there's not much of a difference. So KL, M, N will all behave in a similar fashion, but H is typically too soft and G would be crazy soft. So if you do that, you got your 8-inch wheel, we suggest these parameters. And here's not a huge difference, but 1,000 5/10, 500 RPM, 1,200 RPM, and go anti-directional. So in this particular case, let's go with a different wheel, and then let's go with some different parameters, and we will be able to true that wheel faster with those different parameters. And there's a lot of options here. You can start playing around. If you start getting crazy with really fine grits, we're going to have different recommendations for you. And then there's also the possibility of, if you want to just say, okay, I have this Rush truing wheel, boom. So don't recommend the wheel. I'm using this truing wheel from Rush. Then we're going to recommend, we're going to say, okay, we're going to use this wheel, and then we're going to give you the parameters to use with that. So if you want this wheel, or if you're using this wheel, so sometimes the Rush wheel is the recommended one, sometimes it's not. So in this particular case, if you're using this Rush wheel, we're saying, no, we want you to go with this different Rush wheel, because that one is too soft, too big, whatever, too small, grit size, whatever. Go with this wheel. So you can put in your own wheel, you can put in the Rush wheel, and then if you want to restrict it to different widths, here are some same options with those different widths. And then you can click on that, and boom, it'll tell you, take you to the site to get that wheel. Okay? So the main point is, we want you to use the right wheel. That's really the most important thing. And then we'll give you some recommended parameters if you use the current wheel that you're using or the recommended wheel. Either way, we'll give you parameters. So I won't spend more time on this. You can play around with different options. You can add wheels, you can compare, you can do all types of stuff to say, okay, what do you recommend for different wheels, for different grit sizes, et cetera, et cetera. So it's a versatile program, it's reasonably robust, and you should be able to true a lot faster, somewhat faster, depending on what you're doing right now, if you use the right wheel and if you used our recommended parameters. Okay, and again, just go to Rush Machinery. Here it is up here, Truing Parameters Calculator.